Hi everyone, in this video we're going to go through test number 2 for probability. So all past exam questions and all from exam 2, so you can use your calculator. You'll notice next to the question for the multiple choice I've given the percentage that were correct. So you might like to refer to this to get an idea of, how challenging or easy the question is. Okay, so let's go through them and try to make this video as short as possible. So question 1. The probability of winning a game is 0.25. So nice and easy. P is equal to 0.25. The probability of winning a game is independent of winning any other game. Now, in this question, it doesn't actually state that it's binomial, but there are two things that tell us that it is binomial. The first one being that they're independent. All right, so you can only use binomial when you've got independent events. And we've got a probability of success, winning a game, and we've got a probability of failure. So there's only two possible outcomes, success and failure, and they're independent events. So Ben is playing 10 games, so N equals 10. The probability that he will win exactly 4 times is closest to. So you can see I've defined the binomial distribution. So in the extended response questions, you need to actually state what P and N are if the question is worth more than 1 mark. So we'll come across that in a sec. So this is quite an easy question. Interactive, discrete, and because we only want x equals 4, so it's PDF. Oh, are you working for me? It's so frustrating when it doesn't work. Well, you get the gist. Sorry, I've done the PDF probably up here. Finally got it working. Okay, so x equals 4, the number of trials is 10. And the probability of success is 0.25. So a question like this should be a bit of a gimme question. So 88%. So there we go, 0.145909, so it rounds up to 1460. So 88%. All right, question 2. 71% of students got this one correct. So not as easy as probably the first question, but still probably relatively easy. All right, an archer can successfully hit a target with a probability of 0.9. Sorry, you can see that I've written 0.9. The archer attempts to hit the target 80 times. So we've got n trials. The outcome of each attempt is independent of any other attempt. So that's another clue that it's a binomial. So we can see it doesn't say anywhere in the question that it's binomial, but we're looking for the word independent and the fact that we've got success and failure. So you can either hit the target or you can't hit the target. Should probably underline 80 times too. Given that the archer successfully hits the target at least 70 times, the probability that the archer successfully hits the target exactly 74 times, correct to 4 decimal places, is. So this is a conditional probability question because we've got the phrase given that. So we've got the binomial distribution, but it's conditional probability. So you can see I've set up the notation there. So the x equals 74, given that the probability of x is greater than or equal to 70. And then you just got to work out what they have in common. So I haven't done it for this question, but I will do it now. Sometimes just drawing a number line helps. So what are we going for? Starting from 70, 71, 72, 73, make it a bit longer, 74, 75, etc. So x equals 74 has to equal 74, so there it is. And x is greater than 70 or equal to 70, which is important. All right, and you'd keep going to 80. So the only thing they have in common is x equals 74. So using the conditional probability formula, and this is on your formula sheet. So on our numerator, we have what they have in common. So the only thing they have in common is x equals 74, and then over the probability of B, which is x is greater than or equal to 70. So you'll need to do both of them on your calculator. Just being careful of the inequality sign. So this one is including 70, so your lower limit is 70. Now, I'm not going to do this question if this calculator is not going to cooperate. All right, so far so good. So 74, the number of trials is 80. And the probability of success is 0.9. All right, so that's for binomial PDF, so that's for our numerator. Then we'll just do our denominator, our CDF. All right, so your lower limit is 70. We're including 70, which is important when you're working with discrete. Upper limit is 80. Number of trials is 80, and the probability of success is 0.9. Okay. All right, so on my calculator, I just highlight that to as many decimal places as I can. Oh, we worked out the first one before. I didn't even pick up on that. Over our denominator. So many decimal places will give you a more exact answer. And where did I go wrong there? What did I do? Oh my gosh. I just realized I did a PDF again. Why did I do that? Binomial CDF. There we go. Sorry guys, maybe you picked that up when I did it. Now I knew I got a wrong answer because I shouldn't have an answer greater than 1. So that's when I realized I made a mistake somewhere along the line. Okay. Now that's also wrong. What am I doing wrong? Oh, it's 70. Gosh. Can you tell I'm tired? There we go. Let's try that again. That's better. All right, so there's our numerator. Hold on. There's our numerator. Gosh. Oh, no. That's our numerator, 74. Okay. And our denominator. Oh, she gets there eventually. All right, there you go. Sorry, girls. All right, scrolling down. So the answer is C. All right, question 3, a hard one. So 38%. So a question like this, it's, you know, if you can't do it, which I'd hope you could, but you should just look at your answers, and this is where you're thinking, all right, what options have they given me? We've got a 98, 99, 101, and then we've got 2 lower answers of 37 and 49. So I would say it would be C, D, or E, just because, you know, they're 3 higher values, and I would just pick one of them. But I'm not encouraging you to guess, so let's have a look at how you would actually answer it. So XB is a discrete random variable with a binomial distribution. The mean and standard deviation of this distribution are equal, so that's important to note. All right, so given that P is between 0 and 1, the smallest number of trials N such that P is less than or equal to 0.01 is. All right, so we need to use our expected value formula, or our mean, and there's our standard deviation formula. So they're equal to each other because they said the mean and standard deviation are equal, so you can see I've done that here. And then I've gone through and got P in terms of N. All right, so here. And you could do that on your calculator quite easily. So from this point here, I could have just gone solve, comma for P, and you would get this here instead of doing it all by hand. Now in the question, P is less than or equal to 0.01. All right, so that means 1 because P is equal to 1 over N plus 1. So then I can just solve for N. And again, you can do that on your calculator. So N is greater than or equal to 99. So I've probably done more working out on the page than what you need to do. So you can just go solve where I've put the little asterisks, and you would get this answer, P in terms of N. And then because P is equal to 1 over n plus 1, you can just do solve on your calculator for this, and you get n is greater than or equal to 99. All right, so quite a tricky question. Probably students are able to get started on that one, but maybe not able to continue, but you've got the skills to do it. All right, question 4 wasn't on your page because it was from a Northern Hemisphere exam and I forgot to put it in. Have a go at it. It's actually not a hard question from memory. Oh, I've written Y because it should be a P. Because I just use X and Y on my calculator when I was solving it. All right, so there you can see you're using, so it's told us it's binomial. So we know for the binomial distribution, expected value or your mean is NP and your variance is NP times 1 minus P. So just using those two, and I just did solve on the calculator. That wasn't on your test, but that was quite an easy question. And for Northern Hemisphere, there's not enough students to give a percentage, so that's why there's no percentage there of how many got it right. All right, question 5, 57%. Got it correct. So a discrete random variable x has a binomial distribution with a probability of success of p equals 0.1. So it's told us it's binomial for n trials where n is greater than 2. So remember, for binomial, it is discrete, so it's important that we take note of any inequality signs. The probability of obtaining at least 2 successes after n trials is at least 0.5, then the smallest possible value of n is. Okay, so we don't know what n is, so that's what we've got to work out. And we know n is greater than 2. So we want to do the probability that x is greater than or equal to 2 is greater than or equal to 0.5. All right, so we've done a few questions like this in class. So this is where you're going to use your table. So we'll go interactive, distribution, discrete, and because we want greater than or equal to 2, it's CDF, cumulative distribution function. Oh gosh, I knew this one. Alright, so our lower limit is 2, our upper limit is x, number of trials is x, and the probability of success is 0.1. Alright, so you'll get that error message, just remember to ignore it. We just want to copy and paste that. So copy, and we're going to paste it into graph. Now I've already done that because I checked it before I started doing this. So just copying it in, and just make sure it's ticked, and then we go to the table. Now if you can't see, if you're scrolling down you can't see it, just remember to change your values using this button. So you want your end point to be somewhere close to n. So initially I had it at 5. The error just means because we have to be greater than 2, and if I kept going and I'm like, oh, there's no 0.5, so just changing your end, and I chose 20 because I looked at the options and the highest was 19 on the multiple choice values, so 20. All right, so scrolling down until you get over 0.5, and there you can see 17. All right, scrolling along. All right, question 6, maybe another hard one, 50%. All right, items are packed in boxes of 25 and the mean number of defective items per box is 1.4. Assuming that the probability of an item being defective is binomially distributed, the probability that a box contains more than 3 defective items correct to 3 decimal places is. All right, so I just read through that question, even though I know I chose all these questions because they're to do with the binomial distribution, but reading through, I just got to make sure it is a binomial distribution. So we've got 25, so that's going to be our n, and the mean is 1.4. So I've highlighted those values here. All right, n is 25 and our expected value is 1.4. Given that information, I can find p. So there's p. It is a terminating decimal, but if not, you leave it as 1.4 over 25. You leave it as a fraction. And you could solve that quite easily on your calculator. All right, so let's read the next part. So assuming that the probability of an item being defective is binomially distributed, okay, so that also means it's independent. The probability that a box contains more than, all right, so that wording is extremely important for this question to get it correct. More than 3 defective items, corrected 3 decimal places is. So more than does not include 3. So I've written it out here. Now, if you feel like you're going to get stuck on this, make sure you highlight that and just think, what are you actually finding? So we want more than 3. So basically we want more than or equal to 4 because we're looking at discrete values. So we want more than 3. So our lower value is going to be 4. And our upper value is going to be 25, our value of n. So just going back to our main screen. So our lower limit is 4, upper limit is 25, number of trials is 25. Oh my gosh, it's working. Don't jinx it, don't jinx it. And I just need to move over to see that. So 1.4 over 20, or you could write the decimal. No rounding though, no rounding. And there we go. Oh gosh, where did I go wrong? What did I do wrong? I'm so tired. I'm making mistakes left, right, and center. There we go. That's better. So 1.4 over 25. Okay. Whoops. I hate it when it does that. Let's just keep going. All right, question 7. 59%. All right, binomial random variable x has expected value of 2 and a variance of 4 over 3. So this is requiring you to find n and p. So you've got basically 2 equations, np equals 2. So that's just, np is just your expected value. There's your variance formula. And this is a multiple choice exam, so you should have these notes in your book, and there should really be no reason why this should be 59%. Oh my gosh, it's so low. All right, and this is a question where you just don't plug it into your calculator. You need to actually know what the binomial distribution is. So we want x equals 1, so 6 choose 1, which we know is 6, and you could do this without a calculator too. Times 1/3 to the power of 1 is just 1/3. And you can see it's just left as its exact value. I don't know why I'm writing the same thing again. So just being familiar with the binomial distribution. So 59%, I was quite surprised that's so low. All right, moving along, question 8. All right, so probably the hardest one on here. It's another conditional probability question. So x is a binomial random variable where n equals 20 and p equals 0.88. The probability of x is greater than or equal to 16, given that x is greater than or equal to a, is equal to 0.9175, correct to 4 decimal places, then a is equal to. So conditional probability, the formula is on your formula sheet, but you've also got your book. All right, so just like we did before, we work out, first of all, what they've got in common. So remember, your conditional probability is A and B, what they have in common over the probability of B. So that should be a bracket. So I've drawn this number line just to see what they have in common. So you can see that what they have in common is the probability that x is greater than or equal to 16. There is an endpoint, which I probably should have put on, but that's okay. Over the probability that x is greater than or equal to a. Now, with this question though, we don't know what a is, and that's what we need to work out. So I've just, instead of writing this again, I've just let it equal x. So you can see I've just substituted x on the denominator for probability of x is greater than or equal to a. And then on our numerator, I've worked that out on the calculator. So 0.91728, so just using binomial CDF. All right, so now we've got to work out A. So I've just, remember x is the same as this. So on my calculator, I've just got to work out the probability that x is greater than or equal to A. All right, oops. Oops, where's my calculator? Okay, so binomial CDF. And this is an example where we don't know our lower limit. So it's going to be x. Our upper limit is 20. The number of trials is 20. And the probability of success is 0.88. All right. Oh, let's put it up there. It's annoying. Oh, gosh. Let's do that again. I'm so sorry, guys. All right. Dun, 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 x 20. This is probably a good example of why it's important to get a lot of sleep at night. You make little mistakes like this all the time. All right, copy. So we want to copy that and put it into our graph screen. All right, clear what we had there. Paste the new one in. Tick. And go to our table. All right, so we keep scrolling. What did we want? 0.99976. So you can see there we want it to be so 12, sorry, I'm just looking at my answers, 99976. So the first time it's going to hit that is n equals 12. All right. Now, moving on to extended response. So I didn't do the percentage of marks for these, but these questions weren't too hard. So Micah is flipping a coin. The unbiased coin has a probability of half of landing on heads, half landing on tails. Let x be the binomial random variable representing the number of times the coin lands on the head. Micah flips the coin 5 times. So n equals 5. P equals a half. Now, a lot of you lost marks on this question because you rounded. At no time in the question did it say to round. Okay, did not say give your answer correct to 3 decimal places or 4 decimal places. So you leave it either as 1/32 or 0.03125. You have your calculator, so you don't leave it as a half to the power of 5. So don't round. Otherwise, you get 0 for such an easy question. All right, the next one, x is greater than or equal to 2. Again, easy to do on your calculator, so most of you got that one right, and also did not round, so that's good, but the previous one you did round. Don't round with either, unless it says to round, so maybe start underlining or just writing exact value or round, and then do your question. All right, part 3 is another conditional probability question. So we've got x is greater than or equal to 2, given that x is less than 5. So I've got my, well, that should probably be a closed circle there. All right, and it's worth 2 marks. So you can't go and do all of this on your calculator, or you can, but you won't get full marks. All right, it's worth 2 marks, so you need to show a bit of working out. So what I've got there is more than enough. So here's your conditional probability formula. What I've done here is the number line, so you can see what they have in common, all right, which is extremely important. Now with discrete probability, it's important to know what is included. So 5 is not included. So I've also I've put a open circle there. So the only thing they have in common is the numbers 2, 3, and 4. And then the probability of x is less than 5, so between 0 and 4. All right, so if you got this question wrong, you may have rounded incorrectly. So this was your numerator and your denominator, and most of you wrote that, so that was good. Oh, well, not that, but you wrote a fraction. And if one of them was correct, I gave you the mark. All right, so that's what you should have got for your numerator and your denominator. And if you got that wrong, I'm guessing you may have included the 5. So discrete, just take note of the inequalities. All right, then the expected value. This was done quite well, although you may have lost a mark if you rounded. Okay, at no stage did it say put your answer corrected decimal places. So you leave it as root 5 over 2. Now you have a calculator, so you should not be leaving it as a square root of 1.25. We do not put a decimal under a radical. And you shouldn't leave it as a square root of 5 over 4, okay, because that can be simplified. So you have a calculator, use it. All right, so if you put in square root of 1.25, the calculator will spit out root 5 over 2 to get your 2 marks. So, sorry, I should just go back. It is worth the 2 marks, that question. So also showing some working out. So what I've got there is perfect. Perfect. All right, moving on to question 2, very slowly, come on. Oh, God. Sorry, guys. Come on. Okay. Steve, Katerina and Jess are 3 students who have agreed to take part in a psychology experiment. Each student is to answer several sets of multiple choice questions. Each set has a number of questions, n, where n is a number greater than 20. For each question, there are 4 possible options, A, B, C, or D, of which only one is correct. Steve decides to guess the answer to every question, so that for each question, he chooses A, B, C, or D at random. Let the random variable x be the number of questions that Steve answers correctly in a particular set. What is the probability that Steve will answer the first 3 questions of this set correctly? So you've got 4 options. So the probability of guessing it correctly is 1 over 4. And if you're guessing 3 of them, so it's just 1 over 4 to the power of 3. So leaving it as 1 over 64 is completely fine. At no stage does it say to round. So if you're writing the decimal, it is 0.015625, which is a terminating decimal. And you write 6 decimal places unless it says to round. All right, you're used to rounding to 3 or 4, but unless it says to round, you do not round. All right, so if you rounded there, you got it wrong. Find to 4 decimal places the probability that Steve will answer at least 10 of the first 20 questions of this set correctly. So this is where the binomial comes in, because we want at least 10 of the first 20. So n is equal to 20. And the probability is still 0.25, and it's at least 10, so it's including 10. So on your calculator, you're going from 10 to 20. And the question does say to round, all right, to 4 decimal places. So you do need to round there, and remember a 0 is included as a decimal place. So we've got 1, 2, 3, 4. All right, this next one was worth 2 marks. Oh, no, sorry. Let's go back up. No, that one there was worth 2 marks. Part 2. And it's such an easy one to do on your calculator, but if you just wrote the answer, you're going to get 1 mark. You need to identify the n and the p. So you can either write n equals 20, p equals 0.25, or you can say that it's a binomial distribution, and you're writing the same thing, basically using that notation. All right, and last question, use the fact that the variance of x is 75 over 16 to show that the value of n is. So using your variance formula and just substituting that in and getting n equals 25. Now, at no stage should you substitute this in. So what you do with any show that questions, you go, oh, I did not see that answer. I didn't see it. And you just do the working out and hope that your answer is what you want, okay? Do not substitute in an answer in a show that question. You need to just do the working out. So this was only part of an extended response question, so you may have needed that answer later on. That's why it was given to you, all right? So, or might have needed you to have an understanding of how the variance formula works. But just remember in show that questions, you ignore the answer given and you just do the working out and hope that you get the same answer. All right, girls, fabulous. Bye.